we now discuss the solution of a problem from the section Integral Calculus, and the question is on the definite integral, and this question has appeared in the joint entrance exam main held on 24th June 2022 in the first session. The problem is, let the maximum of the function 9 minus x square by 5 minus x is equal to alpha, where the maximum is taken over all x belongs to the closed interval 0, 2, and the minimum of the same function 9 minus x square by 5 minus x is beta, where the minimum is taken over all x belongs to the closed interval 0 to 2. If the integral beta minus 8 by 3 to 2 alpha minus 1 of maximum of 9 minus x square by 5 minus x, comma, another function x with respect to x is equal to alpha 1 plus alpha 2 log of 8 by 15 to the base e, then alpha 1 plus alpha 2 is equal to. So we are given alpha as the maximum of this and beta as the minimum of this, where the maximum minimum is taken over all x belongs to the closed interval 0 to 2. And this integral beta minus 8 by 3 to 2 alpha minus 1, the maximum of these two functions. First function is 9 minus x square by 5 minus x, and the second function is x, the maximum of this. With respect to x, if it is, when evaluated, alpha 1 plus alpha 2 logarithm of 8 by 15 to the base e, then we have to find alpha 1 plus alpha 2. We now discuss the solution of the problem in detail, and this is the given question what we have just seen. Now we will first find out alpha and beta. So for that we take, let y is equal to 9 minus x square by 5 minus x, and that is equal to 5 plus x minus 16 by 5 minus x. Yes, it is when division, when we take the division, it will be like this. And where x belongs to the closed interval 0 to 2, we mean 0 less than or equal to x less than or equal to 2. And we take its derivative, differentiate, dy by dx is equal to 1 minus 16 by 5 minus x whole square. Yes, it is right. And the stationary points are given by dy by dx is equal to 0, and that is 1 minus 16 by 5 minus x whole square, and that will be, we have taken the LCM, and that we have taken the LCM and simplified, then we have factorized, we got x minus 1 into x minus 9 is equal to 0, and x is equal to 1, that lies in the closed interval 0 to 2, whereas 9 is rejected because it does not belong to the closed interval 0 to 2. So that is the one stationary point, that is the critical point, we got it. And why are we trying here the critical point? See, at critical point, the function y of x, that is 9 minus x square by 5 minus x, how it behaves, that is whether the change of the sign takes place at x is equal to 1, and thereby we can talk about the maxima, minima there. Let's see. Now y at 0, that is the beginning, 0 is 0, put y at 0, that is x is equal to 0 if you put 9 by 5, and we go to the value of y at x is equal to 1, at the critical point it is 2. So what are we observing? Y at 0 is 9 by 5, it is something like 1.8, and this is 2, so that means it is increasing. And now go to the end point, and y at 2 is evaluated and we got 5 by 3. So what are we observing? So as x varies from 0 to 1, it increases, and as x varies from 1 to 2, it decreases. And that means to say at x is equal to 1, it attains the maximum. So y increases in 0 to 1 because 9 by 5 to 2 and 0 to 1, and attains maximum at x is equal to 1 and decreases in 1 comma 2. So y max, that is the maximum value of y, is the value of y at 1, that is 2, and y min, that is the minimum value of this, is the minimum of y of 0, that is 9 by 5, and y of 2, that is 5 by 3. Between 9 by 5, 5 by 3, the minimum is 5 by 3. So alpha is maximum of 9 minus x square by 5 minus x, that is y what we called, and where x varies in the closed interval 0 to 2, and that is y max, that is equal to 2. So thus we got alpha is equal to 2 and beta is equal to the minimum of this 9 minus x square by 5 minus x, which we called it as y, and minimum is taken for all x belongs to the closed interval 0 to 2, and that is y min, which we have already calculated 5 by 3. Thus we got alpha is 2 and beta is 5 by 3. Let's continue in the next slide. We have alpha is 2, beta is 5 by 3. Now we have to evaluate this integral. So how do we do? So integral beta minus 8 by 3 to 2 alpha minus 1. The maximum of the earlier function y of x, comma x. These two functions are given. The maximum from, we have to see in the interval beta minus 8 by 3 to 2 alpha minus 1. So beta is 5 by 3. 5 by 3 minus 8 by 3 is minus 3 by 3, that is minus 1. And 2 alpha minus 1, alpha is 2, 2 2s are 4, 4 minus 1, 3. So the integral is minus 1 to 3, the maximum of 9 minus x square by 5 minus x, comma x with respect to x. And let's call this as the y of x and call this as the z of x. Let y of x is equal to 9 minus x square by 5 minus x and z of x is equal to x, and where x varies in the closed and bounded interval minus 1 to 3. Now let's first of all see where they coincide. So yx, first note down yx and zx are continuous. Yes. And 5 minus x is not 0 in this interval, minus 1 to 3. Yes. And y of x is equal to z of x means 9 minus x square by 5 minus x is equal to 0. Simplify, we'll get 9 minus 5x by 5 minus x is equal to 0. This will imply x is equal to 9 by 5. Again, the same situation has come, and let us compare the values of yx and zx from minus 1 to 9 by 5 and 9 by 5 to 3. So first observe that y at minus 1 is 9 minus 1 by 5 minus of minus 1, that is 8 by 6. And what is the value of z at minus 1? Z at minus 1 is minus 1 only. Which is bigger? 8 by 6 is greater than minus 1. So y of minus 1 is greater than z of minus 1. Yes, move further. So we want to go from minus 1 to 9 by 5. In between we get a 1. So y at 1 is 8 by 4. That is 2. Which is greater than z of 1 is 1. Yes. So it's greater in some point between minus 1 to 9 by 5, that is 1. And at 9 by 5, they coincide. Y at 9 by 5, Y at 9 by 5, and Z at 9 by 5, they coincide. What are we observing? As x moves or x varies from minus 1 to 9 by 5, what are we observing? Y of x is greater than Z of x. So, Y of x is greater than Z of x in the interval minus 1 to 9 by 5. So, that means the maximum of Y of x and Z of x is Y of x. And Y of x is 9 minus x squared by 5 minus x in the interval minus 1 to 9 by 5. So what happens in the remaining part of minus 1 to 3? The remaining part is 9 by 5 to 3. What happens? That we will see in the next slide. And the maximum of 9 minus x square by 5 minus x comma x, that is Y of x comma Z of x, is Y of x, that is 9 minus x square by 5 minus x, which we have already written, in minus 1 to 9 by 5. That is the maximum of this. And what happens to this in the interval 9 by 5 to 3? So that we will discuss in the next slide. We have this, and we will now study the Y of x and Z of x in 9 by 5 to 3. So let's observe that 9 by 5, Y at 9 by 5 and Z at 9 by 5, they coincide, and while traveling from 9 by 5 to 3, we go through the 2, therefore an intermediate a point which is in between 9 by 5 to 3, there is that 2. So Y at 2 is 5 by 3, which we have already calculated, and that is less than Z of 2 is equal to 2. Yes, 5 by 3 less than 2. And at the end point, and Y at 3 is 0. Yes, 9 minus 9, 0 is less than Z of 3 is 3. So what are we observing? So Y of x is less than Z of x in the interval 9 by 5 to 3. So Y of x is less than or equal to we have put because they coincide at 9 by 5. So if you leave that, it is less than. Therefore, who is maximum in this interval? It is Z of x. Maximum of Y of x comma Z of x is Z of x, that is x in 9 by 5 to 3. So max of 9 minus x square by 5 minus x, that is Y of x, x that is zx, which we have already seen, that is a x in the interval 9 by 5 to 3. So we know these ones. So minus 1 to 9 by 5 we know max of that, and 9 by 5 to 3 max of this which we know. We are ready to integrate. So these are the things what we have calculated, and what is that we want to do? So we want to evaluate this integral beta minus 8 by 3 to 2 alpha minus 1, the max of the two functions, first function 9 minus x square by 5 minus x, and the second function x with respect to x. And when evaluated, you will get alpha 1 plus alpha 2 logarithm of 8 by 15 to the base e. And what are these alpha 1 and alpha 2? And once we get it, we add them. That is our answer. So let's see. So beta minus 8 by 3 to 2 alpha minus 1 max of this, and that is minus 1 to 3 max of these. And now this will be broken into two pieces. First is minus 1 to 9 by 5, and in this the max is 9 minus x square by 5 minus x. So this one dx, and plus the remaining part integral 9 by 5 to 3. In this 9 by 5 to 3, the max is x, so x dx. So now integrate, we are ready to integrate. Integral minus 1 to 9 by 5. 9 minus x square by 5 minus x is written as 5 plus x minus 16 by 5 minus x. That is after the division. After the division, it will be like this with respect to x, and 9 by 5 to 3 integral x dx. Now integrate So integral of 5x, integral of x square by 2 minus 16 by 5 minus x integral will be 16 times log of 5 minus x. Yes, it is plus only. Right. And to be evaluated between the limits minus 1 to 9 by 5, the integral x dx is x square by 2 to be evaluated between 9 by 5 to 3. So for the upper limit 9 by 5, the value of this is this one. Yes, 5 into x is 9 by 5 is 5, and x square is 89 by 5 whole square, that is 81 by 25 by 2, that is 81 by 50, plus 16 logarithm of 5 minus 9 by 5 is 16 by 5. For the lower limit, similarly, this is the one what we have computed, plus 1 by 2 into the, for the upper value x square is 3 square, that is 9, minus for the lower value 9 by 5 whole square. So these are the values what we have obtained, and we have written here 9 plus 81 by 50 minus into minus plus 5 minus 1 by 2, and this part when simplified will get 72 by 25 plus 16 log of 16 by 5 minus 16 ln 6. So this is what we have, and we will now simplify this one, that is 18. This when simplified you will get 18, 16 log of 16 by 5 by 6, that is 8 by 5. So ln of 8 by 5, and that is alpha 1 plus alpha 2 times logarithm of 8 by 15 to the base e. And this is given here. So this is the answer what we got, and this is equal to alpha 1 plus alpha 2 logarithm of 8 by 15 to the base e is given to us. From this, alpha 1 is 18 and alpha 2 is 16. So, and we want alpha 1 plus alpha 2, therefore alpha 1 plus alpha 2 is 18 plus 16, that is equal to 34. And our answer for this question is 34. So that is the discussion of the solution of the problem on the definite integrals. It is definitely a difficult problem for the student to answer in the limited time in the examination. However, I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.